I'm going to make an array called Julie. Is there a song like that? An array named Julie? I don't think so. Now, you've never really seen that before. If you look carefully, this is just two square brackets with nothing in it. This is what we call an empty array, which in a vacuum is quite useless. It's a list of nothing. It's like someone giving me a shopping list with nothing on it. Actually, I would love to have that. If my wife gave me a shopping list with nothing on it, that'd be the best shopping trip ever. But that has not happened yet in my life. But this is an empty array. If I wanted to add things to this array one at a time, I could do it as I showed you before. I could say, well, Julie at index 0. Let's just make this my shopping list. So the first thing we're going to get is eggs, right? And then we're going to get milk, et cetera, right? Another way I can do this, if I don't really care the exact order in which these items are dumped in, I can use something called the shovel operator, which would look like this. Those two angle brackets. We'll see why this is useful in a second. So this says, dump eggs at the end of your array. The next line says, dump milk, bless you, at the end of your array. Just put another thing in there. Definitely needs sushi. Right, it's part of the staples of the grocery list. So eggs, milk, and sushi.
What if you do the opposite? Are you able to do it the opposite way?
Yeah, hold on one second. So if I print this out, I get eggs. I get an array containing the string eggs, the string milk, and the string sushi. It is in that order because that is in the order in which Ruby ran these lines, right? Ruby runs line 3, then 4, then 5. In each case, we're throwing on the new string at the end of the array, right? But when I throw eggs at the end of the array, it becomes the only item in the array. When I get to line 4 and throw milk at the end of the array, milk now becomes the last thing in the array. So it becomes eggs, milk. When I get to line 5 and throw sushi at the end of the array, then sushi is now at the end, and it becomes eggs, milk, sushi as we see that final result printed out from line 7. Let me show you how this can actually be really useful. Well, it's useful in many situations, but let's make a new program like this. I'm going to make a new array that's empty. I'm going to give it a variable name called numbers. And I'm going to make one of these interactive programs like we did yesterday. So I'm going to say, please enter 6 numbers, one at a time. And then I'm going to start a loop that runs 6 times. And it will say, please enter a number. And watch what we do here. Numbers, shovel, gets.chomp.2i. This is from yesterday. Let's run this program and then explain it. So please enter 6 numbers one at a time. I'm going to enter a bunch of numbers. So I entered 5, 3, 8, 1, 2, 9. And then at the end, the program said, here are your numbers. And it displays this array of 5, 3, 8, 1, 2, 9. Basically, what's going on is, as I loop through this, just like when you use the equal sign to set a variable, everything that is to the right of the equal sign happens first, and then it gets set to the left. Here as well, when you use the shovel operator, everything to the right of it happens first. So as soon as we say gets.chomp.2i, we enter, this is again from yesterday, we enter a number, Ruby grabs it, converts it to a number, and then shovels it into the number array. So by the time we've completed that loop 6 times, the numbers array contains all 6 numbers that the user had typed in. So this would be useful in context of a program where we want to get a bunch of different inputs from the user and then save them for a later time. It's really convenient if we can store all the user input in a single list. Let's say I wanted to print out your numbers on individual lines, the ones that you entered, without using the put statement. So we would now bring in another loop. So let's say here are your numbers, and then start a loop. And this is very similar to what we had before. We're going to start. Can you still see this when I make it that small? Good, because I can. Index is 0. 6 times do. We're going to say p numbers index. Increase index by 1. And I think that should work. So we entered 6 numbers one at a time, and then it said, here are your numbers, and it printed out each one 6 at a time. So this loop is the loop that gets the user input 6 times. We now have all that input stored within this array called numbers. We then initiate a second loop whose job is simply to print out all the items from that array that we have now stored. Not too different from like a database, right? Where a user enters a bunch of things, it's stored in a database, and then we retrieve it for later usage. But what's interesting here is that in this code, I've never created an array that already had data in it, right? I just started out with an empty array. You'll find that in many of the algorithms you write, very often you start off with an empty array before a loop. That's a very common situation.